accessibility students. It's been far too long since I made a video. So we're going to get a bunch of this. This is going to be related to Lab 3, which is the hex input, and then in a moment I'll make some more for Lab 4, which is a program that you're going to have to debug that computes ISBNs. So the immediate cause of this video is how to do what in a high-level language we call an if statement. And I'm doing this because a lot of the in-class students were having trouble with this concept. So here's the idea. You learned to program using, in high-level languages, statements that look sort of like this. So remember, our registers are basic variables. So you wanted to check to see whether AL was less than or equal to the character, the ASCII character 0. And if that was true, you could do something. And we don't have that directly in assembler. We have to build our if statement, if you will. We have to construct this if statement out of very small pieces of assembler instructions. And that's what your compiler is doing when it's taking your high-level language code and turning it into something the computer can run anyway, but that's what we are doing. So I'm going to suggest that a lot of times what you need to do is you need to think about your if statements in a kind of backwards fashion. So I'm going to suggest the building blocks that we have are going to be compare instructions, and as you know, the result of a compare instruction is left in a flags register for a branch instruction to test. So we could compare AL to an ASCII 0, and the result will be left in a branch flags register, which can be tested to see whether or not it really was less than, or some other comparison. So those are two building blocks. The last building block we have, which you don't think about explicitly, is that code falls through. It goes down line by line by line by line. So that's the other building block that you have, because we don't have, the braces and parentheses or the indentation in Python to put the do something part inside of the if here. We don't really have a way to do that good stuff. So what we're going to do is we're going to start out with our comparison. That's what we need. I was going to do that in orange. So here we have compare AL with an ASCII 0. Like if you just read a character that was typed, it's going to be that. This would be the same as the ASCII 0 would be the same as, of course, hex 31 or decimal 49. Okay. So ASCII 0 is decimal 49 or hex 31. So the character which got typed, which you read, like that. Okay. But we can write it in assembler as that. So the do something part, where's that going to go? Well, we wanted the do something part to be over here, right? Okay, that's where we wanted it to be. So what we're going to do is invert that. If it was greater than or equal to 0, we'll go around the do something part. That's what your normal if does. It has braces here, and if AL was greater than or equal to 0, skip the do something part and continue down here. We do that. We'll invert this. We'll say J, G, E, jump if greater than or equal to, let's pick some label, we'll just call it L1. Okay. And now we'll have our do something. And then we'll have label L1 down here. And we can think of this whole thing as the one if statement. And I'm going to emphasize that think of this label here as part of this block. So that's one thing that students frequently get confused on. They think of the label as being at the start of a chunk of code. And you could, but when you're building this, it's helpful to think of this as the L1 is part of the translated if statement. So if AL is greater than or equal to 0, go to L1, and L1 is here. Okay, got it? All right, so that's a simple if, and that's the way it would usually go in assembler. So now we get to a compound if. Let's say we want to compare AL between 0 and 10. So I said greater than or equal to 0 and less than or equal to 10. Just two arbitrary numbers. Okay, it doesn't have to be AL, maybe we'll say a whole EAX. So I've dropped my eraser. Let's make that EAX, just to be change up a little bit. And again, we have braces in the high-level language around the do something part. So it's going to be the same story. We're going to jump around the do something. We're going to put a label down here. The problem is what to do with this compound if. So we have to check two things. So we know right away we're going to have two checks for EAX against 0 and EAX against 10. So let me just write those in here. Okay, we know we need to do both of those. And we need to put our little pieces of assembler together in such a way that if this whole thing turns out to be false, then we end up at L1, right? Well, how did it turn out to be false? Well, it turned out to be false if EAX was less than 0 or it was greater than 10. So what we're doing here is we're going to say if EAX less than 0 or greater than 10, go to L1, like that. Got it? So this if statement here goes from if this is true, do something, to if this is false, go around. And then the fall through, that third component is the fall through. We do something. So compare EAX to 0. If it's less than 0, we want it greater than or 0. If it's less than 0, J, whoops, sorry, L, L1, okay. Let's see if it's greater than 10, J, G, jump if less than, jump if greater than, L1, and then here is do something. And here's L1. So that's our if. This if statement with the compound thing got converted into, again, mostly what we did was we negated the condition. We took that condition, we did the opposite of it, and if it's the opposite of it, we jump around. All right? Got it. All right. Now I'm going to get to a third type of if. Okay? The third type of if looks like this, and it's pretty common in assembler. You have a bunch of different conditions. This is kind of like a case statement. So if you have like a case statement or a select statement in a high-level language, okay, or you have a bunch of ifs, and a bunch of ifs in a row is achieving the same thing. If this case is do something, if that case is true, do something, if the other case is do something. Typically what you'll do is you'll have your if statements up here, and then you'll go to the various do something things. Okay? So I suggested in your homework that you might want to have a section called hex, or you could do these the same way. You could have, if this is true, then do something over here. If this is true, then do something over here. If this is true, then do something over here. You can do that. That's okay. All right. I'm just showing you another way. Another way is to say, imagine you have go to over here, go to over here. So we're going to have a piece of code called hex. So we'll have a piece of code called hex. And the idea is that if this is true, we're going to go down to hex. If this is true, we're going to go down to hex. The uppercase and the lowercase hex you could process with the same thing called hex in this lab. So what does this look like? Well, we know we have two comparisons with a lowercase a and a lowercase f, right? Okay. Comp. We know we have those two comparisons. So our problem is we want to get down to hex only if both of these, this one is less than, or this one is greater than, if AL is greater than or equal to A, if AL is greater than or equal to A, and this is true, right? So if this first comparison is correct, we need to fall through to the second comparison. We need to do both comparisons. This is an AND situation. We need both comparisons to be true to get down to here. All right? So what we're going to do is we're going to negate the first one. We're going to say JL, okay? And that'll be L1. So we're going to get here if AL is greater than or equal to A. Now the next comparison is to the hex F, or to the ASCII F. Okay? And now we know over here the first part of the condition is true if we got here. So if the second part of the condition is true, we're going to go to hex. So J, L, E. And now here's L1. So this was a little bit tricky. We had to negate the first part. If the first part is false, get out of here. Then we fall through to the second part. If the first part is false, get out of here. We fall through to the second part. If the second part is true, go down to hex. Okay? So that's this if statement here. Okay? And then the next if statement looks very much the same, except it's using the uppercase. We compare AL to an uppercase A. If it's less than an uppercase A, all right. Here was AL. If AL is less than an uppercase A, don't do the rest of this. If it's less than an uppercase A, we get to here. If it's less than or equal to, and it's also, if it's greater than or equal to an uppercase A, we get to here. And if it's less than or equal to F, ALE. Okay? And then we get over here for the not hex case. And then hex presumably is way off somewhere else. Okay, so then here was the label hex. Okay? So that's how you can build. Okay, here's L2. L2 is not hex. So that's how you can build two compound if statements in a row like that, and then you can just gang them up. And then the parts that you go to, here's one that will be called hex, and another one is called decimal. Okay, I'm going to end this video now, and I hope that from these examples of how it's done, you'll be able to take any compound if, break it down into little pieces with control flows, and assemble a block of code. which accomplishes the